Hello, this is gonna start off my Calculus 3 series that I'm gonna go over different problems. I'm gonna first start off with the basics of vectors, then I'm gonna go to doing calculus with vectors, and then I'm gonna go into multivariable calculus with derivatives, and then multiple integrals, and then finally I'll be going to with I'll be doing vector calculus, so multivariable calculus mixed with vector calculus. Okay, so to start off the idea of what's a vector, this is a good example. So a plane is flying horizontally due north at 100 miles per hour, and then a wind, horizontal crosswind, blowing southeast at 20 miles an hour, and then a downdraft downwards at 10 miles an hour. So we're working in 3D space now. So what we want to do is we want to draw a three-dimensional curve. Sorry, three-dimensional graph. Okay, so I'm gonna label it to make sure like we have the direction. So this is up, this is down, this is north, this is south, this is east, and this is west. Okay, so we want to draw like maybe how all of these components of these different vectors. So the plane is flying horizontally due north at 100 miles an hour. So we can call this vector, because we're working in 3D space, we need to have three different components for the vectors. So we can say velocity of plane, v sub p, and then we can note it as because it's flying due north, it's not going horizontally in any way or up and down in any way, so the component is just zero. And then it's flying due north at 100 miles an hour, and so that's the y direction, so 100 miles an hour. And then it's not going up or down, so it's just zero. So we can kind of try to plot it. So it would be probably around right here. Okay, so now the next vector that's affecting this the plane. The horizontal crosswind. The horizontal crosswind blowing southeast at 20 miles an hour. Okay, so when it says southeast, we assume it's always like 45 degrees. So in between south and east, it's exactly 45. So where is southeast? So southeast is about here, but it's at 20 miles an hour. So we can say this is 20, and we travel like about 45 degrees. So it's affecting this plane. Let's say the plane is right here. It's affecting this plane. It's trying to drag it in the southern east direction. We can say horizontal crosswind. So maybe H, or actually let's call it. Let's call it W wind H for like horizontal. Okay. So what are the components? The components of these are a little different. We have to use a trigonometric relationship that exists between here and here. So because the angle is right here, we can say this is sine, and we can say this is cosine. So what we can do with the cosine, that's 45. Sorry, that's 20 times cosine of 45 degrees. Okay, and now, oh, so something I forgot to put is that because the angle is technically negative, we should technically have a negative 45 degrees here. And then same thing goes around for the other one, because if you go this way, you're going around the circle, you're going opposite of the usual way of how we go around the circle. We're going clockwise. So in here we want to put 20 sine negative 45. And then there's no z movement, so up and down movement, so we can just say that's 0. Okay, so now now we want to focus about the last statement, the downdraft downwards at 10 miles an hour. Okay, so it's just a downdraft, so we can just say maybe vector d sub d, and then we can call it and then the components, because it's just a downdraft, there's no horizontal or vertical movement, just up and down movement, so we can say that's 0, and then we can say that's 0, and that's 10 miles an hour, so that's 10. And if we plot it, is negative 10 because it's going down, and then that's technically right here. So the plane is kind of filling a direction towards here a little bit, like towards this direction. And what we want to find out is the actual speed of the plane based on the ground reference. So we can call our unknown vector v ground, the velocity, as if you were on the ground, what would be the speed of that plane if you measure it? Okay, so how can we do that? Well, all we have to do is just add up all of those components to figure out our actual velocity. Okay, so we can say v of the plane, the velocity of the plane, plus w sub h, the wind horizontal, and then the plus d sub d. Okay, so in here we can just substitute in for stuff. So v sub g, we still don't know it. V sub p, that's 0, 100, 0, then plus 20 cosine negative 45, and then 20 sine negative 45, that's 0. And then plus, I need a little bit more room, then plus 0, 0, negative 10. Okay, so now we can just add all of the components together. So what we can do is add all the x's together, add all the y's together, and add all the z's together. But because we're adding all of these vectors, the resulting answer is going to be a vector. It's not going to become a scalar. Scalar is like it's something that just has magnitude. It has no direction. But this still has a direction, because this is the velocity. So if we add everything up and turn into one big vector, we can say 0 plus this, so 0 plus 20 cosine negative 45 plus 0, that's our x component. Now let's go to our y component, so 100 plus 20 sine negative 45, and then that's going to be, and then plus 0. And then for our z component, finally, we have 0 plus 0 minus 10. Okay. So now we can just simplify all of this. So let's simplify it. So cosine negative 45 degrees, that's square root 2 over 2. And then because this is the square root 2 over 2, there's a 2 denominator, so that we can simplify that 20 to a 10. So we have 10 times square root of 2, and then these zeros just go away. And then that's our x component. And then to simplify this, because we're going in a negative angle, the sign is going to be negative because we're going to be in the fourth quadrant. So it's going to be a negative 45 degrees. So it's going to be 100 minus, again, square root 2 over 2 will create a 10 by simplification. So 10 is 10 square root 2. Okay. And then plus 0, which adds nothing to it. Okay, and then here, 0 plus 0 minus 10 is just negative 10. Okay, so that's the vector of our velocity. But I'm asking, okay, what's the actual velocity? So to denote that, we just put this looks kind of absolute value signs, and this is the magnitude of this vector. So what is it? So the way we compute it, we take the square root of, it's pretty much a Pythagorean theorem, because that's what magnitude is. Because a vector is made out of an x and then a y, and the magnitude is the difference between here and then that. If you notice, that's literally Pythagorean theorem. So take the x component, so 10 square root 2 squared plus 10 minus 10 square root 2 squared plus, I'm just going to square these right away, so that'll just be 100. So if we put this in the calculator, we're going to get okay, so I got 87.587. So I'm just checking up with everything correct in the calculator. Okay, so that should be. So the average velocity of the plane is at 4.588 miles per hour. And then finally, if we want to figure out the actual direction of this, all we have to do is just do a little bit of trig and see where this is. So this is a little different, because it's not as easy as just putting the x and the y component. We gotta say, okay, so because we're in multiple quadrants, oh, okay, this is, if we just focus on the x quadrant, on the x and y quadrant, then we just focus on these two, and then we can figure out, oh, okay, that's the angle between here. But if we focus on the y and z quadrant, then we have to focus our angle here. So technically, the direction will depend on what the quadrant that you choose. So for simplicity, we can just choose the x and y quadrant and see the direction based on here. Correct? So all you have to do is put. I'm not gonna do it. You guys can try the different quadrants out and see which you choose the direction. Like I explained, the plane is probably gonna be going in here. Probably. So I mean, we can kind of follow it. So if with the x component, it would be like about here, and then the y component is going to be definitely a positive, so about here. And it's a downdraft, so it's just going to be down here. So it's gonna have an angle like this, and then kind of like an angle like this. Oh no, it's in. Sorry, it's in the. It's down. So it will be here. So yeah, so the direction is a little different. Again, there's no set direction. It depends what plane you choose to follow the to figure out the exact angle. Um, Another thing that I want to talk about before we leave, before this is done, I just want to talk about just a simple um, another property of like how can I create a vector, right? How can I create a vector when I have just points? So we can just call this problem 2. So let's say we have points negative 2, 5, and 3, and then we have a point. So it starts from here, and then it goes to 5, 10, and then negative 5, right? So those are the 2 points, and we want to figure out, okay, how can I turn this into a vector? Well, all you have to do is do terminal minus initial. Okay, so what is terminal minus initial? So all you do, take the end. So this is starting. This is start. This is end. So take the starting one. So sorry, take the end one. So 5. We can just do it right away. So 5 minus 2, so plus 2, and then 10 minus 5, and then negative 5 minus 3. And then if we simplify that, we're gonna have the vector 7, 5, negative 8. Okay, so once we have that, that's the vector between those 2 points. And let's say I ask you to turn this vector into a unit vector. So what is a unit vector? A unit vector is where its magnitude is going to be 1. So how can I turn this thing into a unit vector? All you have to do is take the vector that you have here and do the magnitude of it. So like I said earlier, the magnitude of it, you just do the Pythagorean theorem. So 49 plus 25 plus 64. So what is that? So if we plug into the calculator, that's 49 plus 25 plus 64. So it's going to be about 11.75. So to turn into a unit vector, and we can call this unit vector, maybe we can just call it t. And then all you have to do is just take your regular components and divide it by the magnitude. And then that's the unit vector. So that's it. So I just wanted to go over these 2 problems. So those are kind of the basics of vectors. And like I talked earlier about scalars. And then in the next video, I'll be talking about the dot and the cross products and how to compute them with vectors. Okay, thank you.